Oscillons, they would have been so energetic, their ripples could have unleashed so-called gravitational waves, those vibrations in the fabric of space-time that are generated when monster black holes slam into each other. Future experiments to detect these early universe gravitational waves could give us insights into the most extreme conditions that the universe has ever encountered. Today we will discuss with you about the super powerful particle that dominated the universe right after the Big Bang. Welcome back to Signature's Life, and you're watching Signature's Science. A weird super powerful particle that's not truly a particle could have dominated the universe when it was just a second old, releasing a flood of ripples that permeated all of space-time. Physicists believe that when the universe was very young, it got much bigger in a short amount of time. We call this dramatic event inflation, and it was perhaps the defining event of the infant cosmos. Sometime within the first fraction of a second of the universe's existence, something happened. After the inflation event, something else happened again. We are not exactly sure what. To wind things down and resume a more sedate expansion rate, one that has continued to the present day. Cosmologists are pretty sure that the super-fast ballooning happened in the early universe because today the universe is remarkably uniform at very large scales. A rapid expansion could have done the trick, smoothing out all the wrinkles. Additionally, astronomers have spotted indirect evidence for the inflation event. Inflation didn't just make the universe go big and go home. It also spurred another event called reheating. Whatever triggered inflation eventually died. But as it faded from the cosmological scene, the inflation-causing mechanism released its remaining pent-up energy, transforming this mysterious trigger into a flood of particles that would eventually combine to form protons and neutrons, atoms, molecules, stars, planets, and you. At the same time, as everything in the universe was mushrooming out during inflation, so too were tiny quantum fluctuations in space-time, which stretched into macroscopic differences. Significant bumps and wiggles in the fabric of space-time. These quantum fluctuations meant that some places in the universe had more gravitational attraction than average. In turn, the places of stronger gravity collected bits of material, and those bits of material grew over billions of years, forming the seeds for all the large structures that we see in the cosmos today. And if inflation was capable of all that, it could have generated even stranger things. As for what sparks started the inflation event, physicists have several ideas, one of which involves a quantum phenomenon called scalar fields that extends across all of space and time. A scalar field is basically a fancy way of saying that at every point of the universe, this field has a value of strength but no particular direction. In the modern universe, scalar fields are basically bit players, but the early universe was a much different place, and scalar fields that are rare now could have been in abundance back then. Indeed, some theories of inflation suggest that it was some scalar field that did all the expansion work. You can think of a scalar field like the surface of the ocean. It extends to all sides and out to the horizon, and it has various waves churning across it. Just like in the ocean, waves in a scalar field can sometimes be calm and regular, and sometimes they are erratic and violent. Shortly after inflation happened, right as reheating was kicking in and the universe getting flooded with particles, any random scalar fields hanging around could have been disturbed, like a hurricane opening up above the Atlantic. This could have generated oscillons, which are stable waves that can live for a long time. Oscillons happen in all sorts of situations. For instance, a solitary traveling wave is a kind of oscillon. When oscillons form within quantum scalar fields, they also generate their own kind of unique particles. Those oscillons don't really participate directly in any particle interactions, but the oscillons themselves can still affect the universe. The oscillons would have sloshed around the young universe, and for a brief time the energy contained in the oscillons could have been stronger than the energy contained in any other field or family of particles. With all that sloshing and waving, interesting things are bound to happen. In the case of oscillons, the sloshing could have generated gravitational waves, which are vibrations in the fabric of space-time itself. As the oscillons wave back and forth throughout the cosmos, their extreme energies distort space-time, generating the gravitational wrinkles. Long after the oscillons fade away, the gravitational waves can remain, rippling throughout the cosmos to the present day. While we can't yet observe gravitational waves from the early universe, upcoming detectors like LISA, otherwise the Laser Interferometer Space Antenna, and BBO, otherwise the Big Bang Observatory, should be able to. If this Oscillon picture is correct, this is one potential mechanism for inflation to generate gravitational waves. If we then see those waves, we will get a view directly into the universe when it was under a second old.